Hello, my name is Bernard Trubowitz, and for my final project for this semester's Intro to Alternative Energy, I decided that I would try to build a wind turbine. But not a wind turbine like we saw that powers cities. Instead, I thought it would be interesting to try and build a wind turbine that instead was mounted on a moving vehicle. In this particular case, a car. No, not that kind. The reason that I'm looking at an automobile dates back to an idea that I first had when we were looking at early in the semester on the ways that we could save energy. We learned very early on that too many people, when they go into a room, they ignore this thing, which you wouldn't know what that is because it's a horrible drawing, but if I draw a light bulb next to it, again, looks more like a mushroom, it's a light switch, right? So we ignore these things, and oftentimes if we could just shut off the light, then we would save a significant amount of energy. If you add it all up, we would be pulling a massive load off of our carbon footprint powered power plants, and that would be savings to the environment. But what if you could do this and also at the same time remove those devices entirely from the grid? And that's where the car came in, because we've got, of course, everyone's got a cell phone, and when you're running around, you're dependent on finding a light switch or a power source of some sort, you know, a wall switch, whatever. But instead of charging our devices using those to our, say, in this case, clearly 1980s style gigantic cell phones, instead of using this, hook it up to a mobile source, say an automobile. But obviously we don't just want to use, you know, the car's internal battery, which is charged off of the engine and therefore is not carbon friendly. Instead, what if we could find a way to put some sort of device, perhaps near the front here or up on the top of the roof, maybe mounted somewhere on the hood, and instead use the wind that we get when we're driving, especially on the highway. That's a large amount of wind. Anyone who's stuck their head out or has a dog that does so can attest to this on the highway. You see, my big problem then became, yes, this is clearly going to be an excellent way to power a wind turbine, but the size is an issue. When I went to look for not only small wind turbine kits that I could perhaps work with or try to design on my own, I ran into a size and budget issue. The money, of course, is always going to be a big challenge, especially for a cash-strapped college student such as myself. But here is a picture of a quote-unquote micro wind turbine, at least according to Google. That's mounted on a roof of a house. The blades stick out a good distance. And as you can see by these two gentlemen trying to install another small, quote-unquote, example, they're large, and that would not fit on a car, especially if the blades have to spin as they do in that first picture. You're going to have to mount it rather high and far forward. It'll impede not only vision, but clearly will be a danger of smacking into bridges and garages and things like that. So that's no good. But there's this other idea in wind turbine design that we saw, which is this more elegant one with these blades. Now that's still vertical, but we learned in class that there are horizontal ones that are being thought of perhaps to be mounted on top of highways. I think this is actually the picture we saw in our lectures. That's a really neat idea, and I thought, well, if it works in large scale, why not find a way to mount that horizontal style perhaps onto a car roof, or if you've got, like I do on my vehicle, a large front protective bar in front of the hood, you know, maybe mounted on that, somewhere where it's not obstructive to view. Would that be good enough? Well, no, hard to mount to the hood or the roof, and difficult to design. And then I thought of another technology that maybe had a better solution that could be applied to wind, and that's hydropower. Now, with the hydropower designs we saw, the most efficient ones are using some sort of bladed turbine like these, and all of these are then mounted in a cowling or a hood of some sort, a sheath that allows the water to be directed, usually using a reducer that increases the pressure, like an inverted cone, and then turns the turbine and makes the best use of fluid dynamics. This one in particular, this image, I think, really sums up what I thought I could do. If I could do, instead of doing that obviously with water, why not do that with wind? Now there are, fans already that kind of look like this. This is a perfect example. This is from some sort of gutted electronic or toy, something that I unearthed in my pile of parts in the basement. And it has, it's got this cowling. It's a blowing motor, so it's actually those are spinning to make air come out. But I did find, I'm not going to do it now because I'd have to reach into the frame, but I've got a little LED here, and I found that by blowing a lot of air into this, I was able to get just enough to get this little light to go on. So they can be reverse engineered, which, again, great for me for a project. The challenge then became where to get a motor such as this, and also the battery power. Obviously, if we're going to be building such a design, we've got to be able to store power. And so my idea initially was that you'd have some sort of turbine, and it's in a cowling, and that kind of comes back. It's going to be maybe in a tube, and that tube is going to draw air in, and it's going to narrow as it goes towards the wind turbine. And that's going to increase the speed of the air. And then some sort of pipe that then comes up, perhaps, and allows the air to exit. As much as this looks like a demented slug, however, the principle is sound. The challenge then is where to mount it. Now, if you've got this device, and let's say it looks more like this, without the cutaway, you could have a flexible hose. And that hose could be mounted outside of an automobile window. The exit could also then, again, be kind of loopy and kind of flexible and go wherever. And then you could have leads coming off of this turbine generator unit, and those would then go into through a fuse of some sort for safety, continue maybe a light, and that light would indicate that the charging is occurring, and then finally into some sort of a storage device, a battery. And that battery is going to have to be able to then have an additional outlet that can then go to whatever charging device you're attempting to use. Challenge is this bit here, that battery. Motors I could probably find. I had no trouble finding them, but the battery is a challenge because you need apparently more power coming in than the battery is putting out, which makes sense. And that means if your average cell phone is going to be requiring, say, right around 5 volts in order to operate, you're going to need to be able to store more than 5 volts in that charging unit. And when you're doing that, of course, you then need to be able to safely discharge it. Fires are obviously not going to be good if you're driving around in a car and the thing is right next to you in the cup holder. This is where I had a little more trouble, but I was able to find a company that no longer is in operation that manufactured a combination solar and wind-powered generator system that had its own built-in battery. And I thought, oh, well, that's great. Maybe I can gut that because I was having a little trouble with the math, figuring out, how to safely, what number of rechargeable batteries and so forth. And that's where the parts came in which I started to gut them and try to assemble them into a working device. And these are the parts that I got after I disassembled that commercial unit. Got a solar panel, a little solar cell, which I will not be utilizing for this, although it certainly could be, I imagine, in a more efficient device. For my purposes, though, I'm sticking with just the turbine unit, which I've then cut out of the device's shell. Get to that in a moment. First, I like these batteries. There's 2 cells in these storage units, and they have these little plugs here. These particular plugs then fit into the circuit panel, which I'm very happy to have been able to repurpose. I'm not going to have to use all the parts. This was for the solar cell. These 2 are where the battery leads are going to reconnect back in. This is where the fan goes in. It looks like I cut it, and the reason is I've got these very, very, very flimsy leads coming out of this unit compared with everything else, and I want to actually replace that with some larger wire. It's then got 2 outputs, which I'm very happy to have because it means I can plug into other phones without having to worry about splicing wires and being dangerous. The original unit came with these cords, and the cords in turn come with adapter heads, and so you just kind of clip the adapter heads on in place, and you can charge a variety of devices. And of course the fan itself, which is mounted in this lovely cowling, and I've got these leads on it because I just want to demonstrate an interesting thing I learned. I thought that this was a direct current unit, but I've got my multimeter set to AC current, and it turns out that this has a it doesn't have a commutator, so it's producing AC current, and then the circuit board is running that. So I'm going to try and hold this up out of frame to a hair dryer. It's going to get loud, so I'll have to fix that in post. But so that's just with a small hair dryer. Obviously, the wind is going to be much stronger. Now, I wanted to know how strong the wind would be, and so I employed an anemometer, which I got from the Earth Sciences department, and I had to build a rig to mount that on my car. As these pictures show, what I did is I was able to borrow some camera rigging equipment because I didn't want to drive and try and take readings at the same time. I would not have been able to. Obviously, I'm not going to be using that kind of a mounting bracket. I want something that's adjustable, and the reason I want something that's adjustable is I had, thanks to this, to make some modifications. I originally planned, as I noted earlier, to have piping coming out of the top and the back, and that piping would be out to the elements. But I realized that I might actually damage the components with too much wind. Oh, sorry, that was my clock. And indeed, this particular unit is not rated, is only rated to go up to around 40 miles an hour. If I was to try to utilize the full, say, 80 miles an hour that I might like, I would have needed one of those massive units which has the big blades. And so that's something I actually had to change in my initial planning to actually be practical. So the unit will then have to be able to be pulled into the car, or partially out of the slipstream at least, at higher speeds. And I do have a solution for that, which looks very odd. It's this lamp. It's dead. I've got a bulb in it that I can't get at. But what I'm planning on doing is taking off the mounting pins here and here, and the reason I like that is because I can swivel the head like this, and then this part can be attached to the interior of the car, possibly on one of the door handles. And I'm hoping to mount that cowling right on top of this point so I can go up and down in addition to the first flex, and then I can also turn it very easily. It's just got some very small screws on the underside, and I'm planning on then taking this cowling and in this area back here, drilling 1 or 2 holes in the back end of the cowling like that, and then reattaching all the components. I also have some additional parts which I am planning on adding. I've already got a fuse, thankfully, with the circuit board in place, but I do want a little extra safety, and so instead I've also got a little switch which I will mount. Finally, I have these packages of LEDs which will then demonstrate when I'm driving that the power is being generated. And all of that actually fits in this. This is the size. Now the original unit, if I take some of the pieces out of here, it was a very large unit. I mean, it was very compact for its size, but had a lot of plastic. And I've reduced that considerably. Part of it is because the turbine is not actually going to be attached to the battery unit. Now, this is unfamiliar to many people. It's a slide box. So when you're using slides for slide projectors, which most people don't anymore, you could carry them around in this. And I found that I will be able to mount the circuit board and the batteries inside. I'm going to cut some holes to allow the charging plates to come through and for the wires. And then on the face of it, or the side, I will mount this master switch, which I can then just very easily, it's a knife switch, I can just kind of pull it when if I'm concerned about anything, and that'll just shut the current off. And this is what it looks like set up. Looks a little odd, but what it is you've got the swivel here, comes up and attaches, in this case with just some zip ties, And that allows the fan to be twisted around into a couple different positions to get the best position out the window as driving. It actually kind of already flips up automatically when I open the window. I just got a wire that's running up around through the car and then comes over to my cup holder console, where I've got two very strange looking things. Got a multimeter, which I'm going to use in a minute just to show that it is in fact generating current. As odd as it looks, this is the battery unit. And it looks this way for a couple reasons. Here you can see, here's where I did my best to get those outlets coming through. Fits here. You got your quick switch, so if you want to grab it while you're driving, you don't have to fiddle with any buttons or anything. There's the LED that tells you when it's running. The reason why it looks like a really bad sci-fi prop is because I want to be able to demonstrate that it's generating current, and so I didn't want the leads to be permanently attached. This also means that I can take the wire that's running here and just wrap it around the armature that holds the fan and then quickly pop it out of the car. I suppose Velcro or something would be probably a good way of also operating this. So unfortunately it's not the best time to try to be driving around with a tripod and a window open, especially since it's raining, but here I've got it hooked up to the multimeter, so as soon as I pull this switch, we will begin to get some current. I've got the fan lightly in. So plenty of current is coming in, more than enough to power the battery, and I think that the water from it raining right now is causing a few problems. But if I pull in briefly and switch from the multimeter to the generator unit, all I have to do is turn that off. And the leads just clip right onto the top here. This, again, kind of looks a little like an odd sci-fi device. But that's okay, because the minute that I start driving with this unit and put the switch back on, you'll see that the light comes on, and interestingly enough, again, because it's AC, when it starts up, that light will actually be flashing. It'll be flickering on and off. So I'm hoping that the camera's picking up the fact that it's flashing. Unfortunately, it's a kind of a nasty, rainy day, and I need both my hands on the wheel. But if I pull, since I got one hand busy, if I pull the fan out of the wind, the light should go off. I'm hoping that now I've closed my sunroof, so it's actually a little darker for the camera, and hopefully now you'll see that light actually flickering a lot more. And unfortunately not the best day to try to see this. And the minute that I do get a bit more speed, as that AC current comes in, no worries about the flickering. And because the circuit board is already designed to handle the current coming in as AC, I don't actually have to worry about changing the current over with something like a transformer. I apologize in advance. I'm holding this camera very shakily in the wrong hand for the handle while trying to drive. But you can see as I start to drive now, the turbine almost immediately spools up. And that's another really nice feature of using a commercially developed turbine, is the bearings and everything else are really, really smooth. I've been able to determine that I can blow on this and already generate about a volt current. And so right now I'm driving at about 30 miles an hour. It's very silent, and even with the wind impeding its action, I can charge the battery, from what I've been able to tell, in only about an hour at the most, which is not bad given the capacity of this battery, which, as noted before, is enough to charge 5 regular cell phones. One other nice thing is, of course, that it's very portable, as you can see here. And as I mentioned before, in the car, all you have to do is you just unplug the leads, wrap it around, and you can carry it around very easily. Actually, you know, again, it's about the size of a cell phone, even with that switch, so it's not too hard to get in and out of a car. That being said, one thing that I found as I was going through was I did have to continue to adapt, which I think was an interesting part of this project. I had expected to have the fan inside, again with something coming off the front and the back. At the same time, I was pleased that I was able to get the parts, especially when you consider that the first parts I was looking at were quite large. You can hear that clunk. This is a motor that I was able to pick up actually for free from an electronics company. To give you an idea of, you know, the size and the heft of it, this thing weighs 3 times as much as all of these components combined, and even then, although it turns relatively freely, it's much heavier gauge, would have required a lot more backup systems like fuses and things like that, transformers. And of course the vanes on this would have been enormous in order to get it to turn, compared with this where, you know, I mean, I can just kind of, you know, get my hand like that and it turns. Unfortunately, I did still make one final misunderstanding, which was I put a too large a fuse in here. So on one of the final days of testing, I did manage to elect a new pope. Got a little bit of white smoke that came out of this, and that was the end of the circuit board. I'm afraid I didn't have a chance to order a new one in time for the deadline of this class, which is a pity because I wanted to show off that it was in fact charging, just, you know, hooked into this to a phone. I did a lot of testing off camera, but I was planning on doing this as the kind of the finale, and then managed to fry it before. But overall, it's an effective system. It took me maybe, I don't know, once I had all the components, I'd say it maybe took me 3 or 4 hours to complete. A little bit of soldering work, but that's not too bad if you know what you're doing. And I think that this demonstrates, at least, if not as a beautiful, finished, effective, fully effective product, that it is relatively easy to capture some alternative energy, in this case wind power, and to use that as a way to generate power for small electronic devices, which then don't have to be charged on the grid, and therefore take the load off of more, or I should say less carbon friendly solutions.